Good day, everyone. This lesson or this week is divided into two parts. So the first part is about differentiability and continuity of a function. So in our past lessons, we have already learned about the continuity of a function. Okay, so now, i-recall natin, okay, how to identify if a function is continuous or not, using first the graph and also using the function itself. Okay? So using our graph, so madali lang makita if a function is continuous if we do not encounter any interruption, hole, okay, or any cut in our graph. Okay? For our first function using our graph, as we can see, we haven't encountered any interruption in our graph. So we can already see that this function is continuous. Okay, so for our second graph, we also haven't encountered any hole, interruption, or cut in our graph. So we can also say that the second function is continuous. Now for our third one, we also do not encounter any interruption in our graph. So we can already say that our function is continuous. Okay. So using our function, paano natin ma-identify? Using the test of continuity. So for our first one, okay, y is equal to x raised to 2/3 at x is equal to 0. Okay, so is the function continuous at x is equal to 0? So let's find out using the testing of continuity. Okay, so the first test is if f of c exists. Okay, so f of 0 is equal to 0 raised to 2/3 is equal to 0. Okay, so 0 is still a value. Okay, so f of c exists. So the second test is finding the limit of the function as x approaches 0. Okay, the limit of x raised to 2/3. Okay, so we just also have to substitute the value and we also get 0. Okay, so 1 and 2 have the same value, which is 0. Thus, we can say that the function is continuous. Okay, so that is our recall on continuity. Okay, so now we will jump to the term differentiability. So what is a differentiability? Okay, so how can we say that a function is differentiable or not at a given value of x? So a differential function of one real variable is a function whose derivative exists at each point in its domain. Okay? So sabi dito, a differentiable function daw, okay, is one real variable is a function whose derivative exists. Okay? So dapat daw nag-e-exist yung derivative niya at each point in its domain. Lalo na pag may given tayong x is equal to c or a certain point. Okay? So comparing differentiability and continuity. Okay? So the relationship between continuity and differentiability is summarized below. Okay? So number one if a function is differentiable at x is equal to c, then it is continuous at x is equal to c. So differentiability implies continuity. So anong sinasabi dito sa unang sentence natin? Okay? So kapag tinest daw natin yung differentiability at x is equal to c, okay, and we found out that the function is differentiable, automatic continuous na rin siya at x is equal to c. Okay? So for our second one, it is possible naman for a function to be continuous at x is equal to c and not be differentiable at x. Okay? So dito naman sinasabi, hindi porkit continuous na ang function, ay differentiable na siya. Okay? So, malinaw po yon. Kapag differentiable ang function, automatic continuous. Pero kapag continuous ang function, hindi automatic na differentiable na siya. Okay? So, here in our graph, at the upper right corner, we have an example of discontinuous function because we have encountered an interruption at x is equal to a. Okay, and in our second graph, okay, a vertical tangent line means okay, undefined yung kanyang derivative at x is equal to a. So this is an example of not differentiable at x is equal to a. Okay, so that is the relationship between differentiability and continuity. All right, so now we will have to test the differentiability and continuity of certain functions. So for our first example, we have f of x is equal to x minus 1 squared at x is equal to 1. So this is an example of a parabola. So this function is a parabola. So first, let us identify if the function is continuous or not using the test of continuity. All right, so the first one is we will have to test if f of c exists. So f of 1 is equal to 1 minus 1 squared is equal to 0. So the next we'll have to test the limit if it exists. So x minus 1, the limit of x minus 1 squared, that is our function, the given function, as x approaches 1. Okay, so similar to the first one, we will just have to substitute 1 to our function. So 1 minus 1 squared is also equal to 0. So the first and second test exist. Okay. So we can say that the function is continuous at x is equal to 1. And also, we have seen that the first and second value is the same. Okay. The evaluation of function and the limit is the same. Okay. So now we will test the differentiability of this function. Okay. So the function is said to be differentiable if the derivative exists. So we have also learned how to find the derivative of a function at a certain value of x. So we have this formula f prime of x is equal to the limit of f of x minus f of x sub 0. This f of x sub this x sub 0 is the given value of x, which is 1 over x minus x sub 0 as x approaches x sub 0. So we will just have to substitute the given to our formula. All right, so for the first one, we will just have to find f of x sub 0. So that is f of 1. Okay, so this is f of x sub 0. That is equal to f of 1 equals 1 minus 1 squared. That is 0. All right. So we have already found the f of x sub 0. Next, substituting f prime of 1 is equal to the limit of fx minus f of 1 over x minus 1 as x approaches 1. Okay, substituting f prime of 1 is equal to the limit of, okay, so f of x, ano ba yung f of x? That is the given function, which is x minus 1 squared minus f of 1 is equal to 0 all over, okay, copy x minus x sub 0 is 1 as x approaches 1. All right. So simplify our function. We get the limit of x minus 1 squared over x minus 1 as x approaches 1. Okay, so hindi natin pwedeng basta i-substitute yung 1 sa ating function dahil mag-undefined yung ating answer. Okay, so simplify further. We get f prime of 1 cancel out. Okay, yung x minus 1 na isa. So matitira ay yung x minus 1 sa numerator. So we have the limit of x minus 1 as x approaches 1. That is the final value. Okay, so 1 minus 1 is equal to 0. All right, so f prime of 1 pala is equal to 0. Okay, so we have already learned the concept of the derivative. Okay, so that means f prime of x is also the slope of the tangent line. So, nasan ba yung 1? X is equal to 1 is andito po. Okay. So, the slope of the tangent line. Okay. So, we will draw the tangent line. Okay. So, straight horizontal line. And that has a slope of 0. So, we have found out using our formula. All right. So, it exists. So, meron siyang slope and meron tayong nakuhang value which is 0. Okay, real number. So, the function is said to be continuous and also differentiable as our final answer or conclusion. Okay. So next, let us have another example. So we have x raised to 2/3 at x is equal to 0. So is this function continuous and differentiable at x is equal to 0? So let's find out. First, finding or testing the continuity, we have f of 0 is equal to 0 raised to 2/3 is still equal to 0. Next, we have the limit of x raised to 2/3 as x approaches 0 is equal to 0 raised to 2/3. So that is also equal to 0. So we got value of 0 for the first and second test. Okay. So the third one, since they have the same value, which is 0 as well. Okay, so the function is continuous at x is equal to 0 as well. Okay, so continuous siya. Okay. So we have to test for the differentiability of this function. Since, again, hindi porket continuous ang function natin is differentiable na siya. Okay, so let's have the test for differentiability. So the function is again said to be differentiable if the derivative exists. Okay, so we have to evaluate the derivative of this function. So again, we will use the formula f prime of x is equal to the limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub Okay, so first, we have to evaluate f of 0 to be used in our formula. So f of 0 is 0 raised to 2/3. That is also equal to 0. Now, f prime of 0 is equal to the limit of f of x minus f of 0, since x of 0 is the given value of x. Okay, and then over x minus 0 as x approaches 0. Substituting, f prime of 0 is equal to the limit of x raised to 2/3, the given function, minus 0 over x minus 0 as x approaches 0. Simplify the function, we get the limit of x raised to negative 1/3. So, saan nakuha yung negative 1/3? We have here x raised to 2/3 over x. Okay. So, the rule of exponent. Okay. So, kapag meron sa numerator and denominator na the same variable tapos may exponent, we just have to subtract the exponent of the denominator from the numerator. So 2/3 minus 1. Okay, the exponent here is 1. The answer is negative 1/3. Okay, so dun nakuha yung exponent niya na negative 1/3. So we have f prime of 0 is equal to the limit of x raised to negative 1/3 as x approaches 0. So that is also equal to, since negative 1/3, kapag fraction ang exponent natin, that means root siya. Okay, so since 1/3, that is cube root. And negative, so sa baba siya mapupunta. Okay, so that sa denominator. So that is also equal to 1 over cube root of x. All right, so we will have to evaluate the limit of 1 over the cube root of x as x approaches 0. So we have to substitute 0 sa ating function and magkakaroon tayo ng value of 1 over 0, which is undefined. Okay? So the limit or the derivative does not exist. Okay? If it doesn't exist, the function is said to be not differentiable. Okay, so the function, for our conclusion, the function is continuous but not differentiable. All right, so I hope na nagets po ang concept ng differentiability and continuity. Okay, so just remember, in the relationship of differentiation and continuity of functions, it is possible for a function to be continuous at x is equal to c and not be differentiable at x is equal to c. Tulad ng last example natin. So, continuous siya pero hindi differentiable. So, continuity does not imply differentiability. But differentiability always imply continuity. Okay? So, kapag tinest nyo yung differentiability niya tapos differentiable yung function, automatic again, continuous siya. Okay? So, kung nakikita natin dito sa diagram natin, nakapaloob si differentiable function sa continuous functions. Okay? So, all differentiable functions are continuous functions, but not all continuous functions are differentiable functions. That's it for differentiability and continuity of functions. We will now jump to our second part of the lesson, which is the differentiation rules. So we have grasped also or learned about the concept of the derivative in our past lesson or in our lesson last week. Okay, so the derivative of a function at, so that is f prime of x. Okay, so this derivative at a given value of x is also equal to the slope of the tangent line. Okay, so now let us recall. So find the derivative of the following function. So derivative, pag walang given na point, we have to use the formula f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So we will use this formula to find the derivative of this certain function. So let's have number 1. So f prime of x is equal to the limit of x plus h minus f of x over h as h approaches 0. So that is the formula. Substitute. So f of x plus h, we will just have to substitute buong x plus h sa ating function, okay, sa ating x. So f prime of x is equal to the limit of x plus h cube. Okay, parang ipinasok natin tong buong x plus h dun sa x. So that will be x plus h cube minus x cube, the given function, over h as h approaches 0. Okay? So we have to cancel out h sa ating denominator. Kailangan mawala yan dahil hindi natin basta pwedeng i-substitute yung 0 sa h. Okay? Since h is in the denominator. So we have to expand these terms. So we have x plus h cubed is equal to, okay, ang expanded form niya ay x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed over h. Okay, so cancel out x cubed since x cubed minus x cubed is 0. So we get, okay, so these are the same. Okay. And then ang matitira ay 3x squared h plus 3xh squared plus h cubed all over h. Okay. Evaluate the limit as h approaches 0. So we have to factor out h since every term in our function have h. Okay. Pwede tayo mag-factor out ng isang h sa labas. Ang matitira ay 3x squared plus 3xh plus h squared. Okay, and then canceling out h, we get 3x squared plus 3xh plus h squared. So we have canceled out the h at the denominator. So we can substitute h in our function. So 0, h approaches 0. So we just have to substitute 0 sa ating h. So we get f prime of x is equal to 3x squared plus 0. Bakit naging 0? Dahil sinubstitute natin yung 0 sa h. Okay, and then another 0 because 0 squared is still 0. So further simplifying, we get the final derivative of the function which is equal to 3x squared. So that's it for our derivative, finding derivative of our function. All right, so try this yourself. Find out the derivative of these two remaining functions using this formula. Okay, so katulad lang din ng ginawa natin, we just have to substitute x plus h sa ating function, and then find the limit as h approaches 0. So, dapat ang makuha nating sagot ay f prime of x is equal to negative 1 over x cubed. And then for our third example, we get f prime of x is equal to negative 2 over x minus 1 squared. So that's for the derivative of the remaining two functions. All right. So now we will jump to the differentiation rules. Okay. So baka iniisip natin, ang haba masyado ng formula na to, sir. So, meron kayang shorter method of finding the derivative of the function? So, the answer is yes. And we will just have to use the differentiation rules. So, dito na po papasok yung rules in differentiation natin, okay, to make our computation shorter and easier. Okay? So, for our first task, we have to have a function. So let y is equal to f of x. So note any pattern and use these to determine the derivative of other functions. So now, this is an example. We have the function f of x is equal to x squared. Ang derivative niya ay 2x. Next, we have f of x is equal to x cubed. Ang derivative niya ay 3x squared. Next, f of x is equal to x to the fourth. Ang derivative niya ay 4x to the fourth. So you can try if tama ba na ito yung derivative niya using yung mahabang formula natin. Okay? So but here, ang ninonotice natin is yung pattern na nangyayari sa ating derivative. Okay? So kung mapapansin natin, meron siyang pattern. Okay? So, all right, yung coefficient, no? Pansin natin, yung coefficient, yun yung exponent. Okay? And then, meron pa rin siyang kasamang x na nakari sa exponent. Okay? So, this is 4x cubed dapat. So, now we have the derivative of f of x is equal to x raised to 5. We get, okay, 5 yung exponent. So, ang magiging coefficient niya ay, okay, so maybe 5. Let's find out. So, 5x to the fourth. Okay, kung mapapansin natin yung exponent natin, okay, saan nakukuha yung exponent? Na ma-minusan siya ng 1. Okay, so yung exponent na given, okay, pumupunta siya sa unahan, nagiging coefficient, and then na ma-minusan ng 1. So, that is the pattern in finding derivative of this certain function. So x raised to 6 will be, okay, so this is f prime, since we already get the derivative. So lahat po yan ay f prime of x. So f prime of x is equal to 6x raised to 5. For our guide questions, okay, first question, based on the pattern, what is the derivative of a function in the form f of x is equal to x raised to n? N is any real number. Okay, so n is any exponent of x. Okay, ano daw yung napansin nating pattern for this form? Okay, so x tapos naka-raise siya sa exponent. So we call this the derivative of a power rule. Okay, kung mapapansin natin, again, yung exponent na n natin, x raised to n, okay, so bumababa siya, nagiging n raised to n times x raised to n minus 1. Okay, so that is finding the derivative of a power rule or cx tapos meron siyang exponent, any real number exponent. So how does it compare to the previous method that makes use of derivative definition, yung may formula na limit of f of x plus h minus f of x over h as h approaches 0. So this uses the definition of a derivative. Okay? So how does it compare? So napakadali na nating makuha yung derivative ng function. Hindi na natin kailangan pang gumamit ng mahabang formula na to. Okay? So masasabi natin na this is the shorter method of finding the derivative of certain functions. All right. So let's now have the derivatives of a function. So the basic rules of differentiation are presented here along with several examples. So remember that if y is equal to f of x is a function, then the derivative of y can be represented, lahat to ay ibig sabihin ay derivative. So f prime of x dy over dx. So derivative of y with respect to x, dy over dx. Derivative lang din yan. Y prime, pwede rin gamitin. Okay? So lahat yan ay derivative ng function. Alright, so let's now have the rule number 1. What is the rule number 1? It is called the derivative of a constant. Anong sabi dito? The derivative of a constant is always 0. So kapag pinahanap sa atin yung derivative ng any constant, for example, differentiate f of x is equal to 30. So 30 lang yung given natin. Okay, that is a constant. The answer for f prime of x or the derivative of x of our function is 0. Okay? Pag tinanong ko kayo, what is the derivative of f of x is equal to 1,000. Okay? So the derivative is automatically 0 since 1,000 is a constant. So f of x is equal to pi. Still, f prime of x is equal to 0 since pi is a constant. That is for rule number 1. For rule number 2, ito yung na-try natin kanina. That is called the power rule. For the derivative of x raised to n, x tapos naka-raise siya sa any exponent, that is n times x raised to n minus 1. Okay, again, bumababa, imagine natin, bumababa yung n or yung exponent, tapos namaminusan ng 1. For example, so let's have the derivative of f of x is equal to x raised to 4. We have f prime of x is equal to 4x cubed. Okay? So, bumaba yung exponent, naging coefficient, and then na-minusan yung exponent ng 1. So, that is 4 minus 1, we have 4x cubed. For our third rule, the derivative of a constant times a function. So the derivative of k times the function, where k is constant, okay, that is k times the derivative of the function. For example, we have y is equal to 5x cubed. 5x cubed. Okay. So, madali lang din po to. Parang isasantabi muna natin yung 5. Okay. So, since constant siya, we get f prime of x will be multiplied, okay, 5 times the derivative of x cubed. Okay. Derivative f prime of x cubed. Okay. So we get, okay, ano ba yung derivative ng x cubed? Okay. K is equal to 5 and f of x is equal to x cubed. We get f prime of x is equal to 5 multiplied to 3x squared. Bakit 3x squared? Since we have x cubed, tapos bumaba yung 3, naging 3x. Okay, 3 minus 1, we get 3x squared. Okay, tapos i-multiply natin siya sa 5 since meron siyang given na coefficient of 5. Okay, so parang power rule lang din pero may coefficient sa unahan, na multiply lang yung exponent tapos yung given na coefficient. So another example we have y is equal to 3x to the 4th. Okay? So mabababa lang yung 4. Okay? So y prime is equal to, okay, again y prime is also derivative. Y prime, so 3 times, okay? So yung 4 tapos x raised to 4 minus 1. So the final answer is 3 times 4 is 12, x raised to 3. All right, so that's it for the derivative of constant times a function. Diba? Madali lang. Madali na lang makuha yung derivative ng function kahit hindi natin gamitin yung long method na formula. Okay, so we have the rule number 4, the derivative of a sum or a difference. So if we have two functions tapos pinag-add siya or subtract, so the derivative is equal to the sum and difference also of the derivative of each term. Okay? So ano ibig sabihin nun? For example, we have differentiate f of x is equal to 3x squared minus 7x. Kung mapapansin natin dito, meron tayong dalawang term, pinaghiwalay siya ng subtraction sign. So, isa-isa yan, if hahanapin natin yung derivative and then, tsaka natin ipagmaminus din. So we have u of x, that is 3x squared, yung unang term. V of x is equal to 7x. Okay, so the derivative of each is 6x and 7 using the previous rule. Okay, 3x squared, derivative niya ay 6x. Si 7x, derivative niya ay 7. So f prime of x, pagsasamahin lang natin, 6x minus 7. Next rule, we have the product rule. Pag product naman, we have u of x times v of x. Okay, so the derivative is equal to the u times the derivative of v with respect to x plus v times the derivative of u with respect to x. So anong ibig sabihin nun? Ang derivative daw ng dalawang function na pinag-multiply ay equal sa, okay, copy the function u, multiply mo dun sa derivative ni v. So u dv plus yung v naman, then i-multiply mo sa derivative nung kasama niya. So that is the product rule. So let's have an example. We have 6x squared plus 2x, tapos yung isang function ay minultiply sa x cubed plus 1. So we have two functions here na pinag-multiply sa isa't isa. Okay, let's find the derivative of each function. So we have u of x is equal to 6x squared plus 2x. Yun yung unang function. Tapos yung pangalawa ay x cubed plus 1. Okay. So find the derivative of each. So the derivative of u with respect to x is equal to 12x plus 2. Tapos yung isa ay 3x squared. Itong si x cubed plus 1. Alright. So sabi, ang derivative daw ng product ay, okay, copy yung u, yung unang function. That is 6x squared plus 2x. Multiply mo dun sa derivative nung katabi niya. So that is 3x squared. Hindi pa po tapos. We got plus, i-add mo. Okay, sa v naman, v of x, multiply naman sa derivative ng u or yung katabi niya. Okay? So parang partner-partner lang. Simplifying our derivative, we get 3x to the fourth plus x cubed, 8x cubed plus 12x plus 2. So that's it for the product rule. Kung meron tayong product rule, meron din tayong, of course, the quotient rule. So, paano yung quotient rule? We got for the derivative of f of x, okay, merong function sa numerator, tapos merong function sa denominator. That is the quotient. Okay. So, the derivative of this form is equal to, so the v, okay, so yung nasa baba ay designated as v. Okay? So, yung denominator, which is v, multiply mo sa derivative ng numerator. Okay? So, dy over dx, ano natin sa word, okay? The denominator multiply to the derivative of the numerator minus the numerator multiply to the derivative of the denominator. Okay? All over v squared daw. So, i-square mo yung nasa denominator. So, denominator, i-erase mo sa 2. Okay? So, for example, we have differentiate f of x is equal to x squared plus 7 over 3x minus 1. So, this is the numerator function, the denominator function. So, u of x is equal to x squared plus 7 and v of x is equal to 3x minus 1. The derivative of each is 2x tapos 3. Alright? So, let's find out the derivative using the quotient rule or the formula. Okay? Again, the derivative of a quotient is equal to the derivative of the new denominator multiplied to the derivative of the numerator. Okay, so that is 2x minus derivative or copy the numerator multiply to the derivative of the denominator. All over, ano ba yung denominator? That is 3x minus 1. Okay. Tapos, square lang natin. So, that's it for the quotient rule. The chain rule naman. So, sabi dito, if y is a function of u, so y is equal to the function of u, and u is a function of x. For example, u is equal to g of x, another function, then the derivative of y with respect to x is equal to dy over dx is equal to the dy over du over du over dx or times du over dx. Let's have this example. The given function is f of x is equal to x squared minus 5 raised to 4. So we have to differentiate that or find the derivative. Ile-let natin, i-encapsulate natin yung nasa loob ng parenthesis natin. Okay? Kung mare-recall natin, para siyang nasa form na x to the fourth. Pero yung pinakaloob natin or yung base natin ay x squared minus 5. Tapos ni-raise siya sa 4. Okay? So anong mangyayari dito? We have to let this function nasa loob lang ng parenthesis to u. So let u is equal to x squared minus 5. And then y is equal to u to the fourth. Okay? So u to the fourth na siya. Okay, again. But naging u to the fourth? Kasi itong buong u na to ay nilet natin. Okay, equal siya sa x squared minus 5. Okay, so we have dy over du is equal to 4u cubed. Okay, so power rule. 4u cubed and du over dx is equal to 2x. Ano tong 2x or yung du over dx? That is the derivative of the, okay, yung nasa loob ng parenthesis. Okay? Multiplying each 4 times u cubed times 2x. So we have 4x squared minus 5 raised to 3 multiply to 2x. So para di tayo malito, ito ay yung 4u cubed. Okay? So that is the derivative of y with respect to u. Okay? So yung power rule ng kabuuan. So 4 times the x squared minus 5. Tapos yung x squared minus 5, may exponent pa siya na 4 minus 1. Mababawasan ng isa, kaya naging 3. Tapos yung nasa loob, meron pa siyang derivative eh. So that is 2x. So imo-multiply lang natin. Further simplifying, we get 8x times x squared minus 5 raised to 3. Okay. So another example for the chain rule para hindi tayo malito. So for example, ang given natin ay y is equal to x minus 5. Okay. Erase natin sa 5. Alright. So ang chain rule ay, okay, so power rule lang din to. Bababa si exponent, okay, ibaba natin. 5, magiging coefficient siya, multiply 2. Okay, yung nasa loob kasi ang exponent ng buong to ay yung 5. So copy x minus 5 and then 5 minus 1. Oops, hindi pa tapos. Chain rule siya. Meron pang derivative itong buong to. Okay, yung kinapapalooban ng ating exponent. Sakop kasi ng exponent natin na 5 yung buong x minus 5. So x minus 5, ang derivative niya ay only 1. Okay? So again, bakit naging 1 yung derivative ng x minus 5? Since the derivative of x is equal to, okay, may exponent yan na 1. So 1x raised to 1 minus 1, that is 0. So that is 1 multiplied to x raised to 0. Any number raised to 0 is equal to 1. Minus the derivative of a constant is 0. So the answer is 1 for the derivative. Okay, so now we get y prime is equal to 5 times x minus 5 raised to the fourth. Okay, so yun lang yung sinasabi ni chain rule. Okay, parang power rule lang siya pero nadagdagan kasi may derivative pa yung nasa loob niya. Hindi lang siya basta x na naka-raise to any number. Okay? So itong x na to, parang may ibang term siya or hindi lang siya basta x. Okay? So under logarithm naman tayo. So ano kayang derivative ng logarithms? So first, the derivative of a natural logarithm ln of u. Okay? So derivative of a given y is equal to ln of u of x. Okay? According to the chain rule, we have the derivative of ln of u is equal to 1 over u. Okay? Yung kasama ni ln, okay, bababa siya. Okay? So for example, ito yung u natin. So naging denominator 1 all over u, tas the derivative ng ating u, du over dx. So that is our y prime. Let's have an example para mas maintindihan. Differentiate f of x is equal to ln of 2x plus 3. Alright, so dito na agad tayo tingin sa derivative. Anong nangyari? Okay, itong 2x plus 3 natin, bababa siya, magiging denominator. So 1 all over 2x plus 3. Okay, hindi pa tapos dahil may derivative pa yang kabuuan na yan. So derivative ng 2x plus 3 is mamumultiply to, okay, or is equal to 2. So the derivative of 2x plus 3 with respect to x is equal to 2. So that is the valued multiplied to 1 over 2x plus 3. Further simplifying, we get 2 over 2x plus 3. Okay, so another example, y is equal to ln of 3x. So y prime is equal to, since natural logarithm yan, so we have 1 over 3x. Oops, tapos na ba? So hindi pa, dahil ito ay may derivative pa. So ang derivative ng 3x ay 3. So we get 3 over 3x. 3 over 3x. We can cancel out 3. So the final answer will be 1 all over x. Let's have rule number 9. Logarithm of u with a base a. Ito kasing ln, so para lang din siyang natural logarithm, pero iba ang base. Ito kasing natural logarithm natin ay base e yan. So may base lang siya na e, pero ito, iba yung base niya. So let's have an example. So, okay. So let's have definition muna. So the derivative daw ng logarithm with a different value of base aside from e is equal to, okay, so ito po yon, 1 all over ln of a, okay, 1 over the natural logarithm nung base natin, multiply to, okay, 1 over u, parang natural logarithm lang pala, no? And then du over dx. So ang nadagdag lang dito, kung mapapansin natin, ay 1 over ln of a. Tapos para ka nang nagde-derivative ng natural logarithm. Let's find out using the example. F of x is equal to the logarithm of 2x plus 3 with a base 3. So may base na siya na 3. Ang base natin ay 3. Okay, so the derivative will be laging 1 all over the natural logarithm or ln of 3, okay, multiply to 1 all over yung kasama nung logarithm natin. So logarithm of 2x plus 3 kaya naging 1 all over 2x plus 3. So tapos na ba yon? Hindi pa po. According to chain rule, yung nasa loob ng ating logarithm ay may derivative pa. So the derivative of 2x plus 3 with respect to x is equal to 2. Okay? So derivative ng 2x is 2. Derivative ng 3i 0. So that is equal to 2. Okay? So simplify. 2 over ln of 3 times 1 over x 1 over 2x plus 3. That is our final answer. That's it for finding derivative of logarithms. Okay? So you just have to practice para hindi malito. Let's have another example. So y is equal to the logarithm of 2x minus 1 with a base 3. Ibahin natin yung base. With a base 5. Okay? So, ano kaya yung derivative niya? So, y prime is equal to, okay, we have a base of 5. So, automatic meron siyang 1 over ln of 5. Okay, multiply to itong 2x minus 1 natin, bababa. 2x minus 1. Okay, tapos na po ba? Hindi pa. May mamumultiply pa siya sa derivative no ating kasama ng logarithm. Okay, so 2x minus 1, ang derivative niya ay 2. So simplify, we have 2 over ln of 5 multiply to 1 over 2x minus 1. So pwede na po yan. That is our final answer. 2 ln of 5 times 1 over 2x minus 1. Punta naman tayo sa exponential functions. So, derivative ng exponential functions. First, if meron tayong given na function, y is equal to, okay, na ganito ang form, tapos naka-raise sa function u of x. Okay? Copy the exponential function. Copy lang yung exponential function. And then, multiply to derivative nung exponent u of x. That is, dy over dx is equal to, okay, kinapi lang, e raised to u of x times the derivative ng exponent. Let's have an example. So, for our example, y is equal to e raised to 2x plus 3. Ano ba yung derivative niya? So, as observed, okay, 2 times, ito yung derivative niya, 2 times e raised to 2x plus 3. So, as observed daw, the function is copied and multiplied to 2, which is the derivative of the exponent. So, that is y prime is equal to, copy lang daw yung exponent, yung ating exponential function, 2x plus 3, multiply to the derivative ng exponent. That is 2. Okay? So, sinimplify lang. Mas magandang tingnan na nasa unahan ang coefficient. Alright, so that's it for the derivative of exponential functions. Let's have another example. We have y is equal to e raised to 4x minus 1. So 4x squared minus 1. Okay, so y prime, copy lang daw, e raised to 4x squared minus 1, multiply to derivative ng numerator or na exponent, that is 4x squared, ang derivative niya ay 4 times, okay, bababa yung 2, x raised to 2 minus 1, okay, minus derivative ng 1 is 0. Okay, simplify natin. Y prime is equal to e raised to 4x squared minus 1 times 4 times 2 is 8. x to minus 1 is 1. Okay, so that is our final answer. So 8x times e raised to 4x squared minus 1. All right. So for our final rule, all right. So kung meron tayong base na e, okay? Ang base natin dito ay e. Ngayon naman, paano kapag iba po yung base? A naman or any number, any real number. We have the derivative is, okay, so this is the answer. The ln, the natural logarithm of a multiply to, okay, kinapi lang yung function, exponential function, and then derivative again ng ating function. So para lang din pala siyang derivative na exponential function. Pero ang nadagdag lang ay itong natural logarithm of a. Kasi nga, hindi na itong ating base. Hindi kagaya dito. Okay? So, ln of e lang din kasi ay equal to 1. So, parang nawala lang yung ln of a for the derivative of exponential function with a base e. Let's now have the example y is equal to 10 raised to 5x minus 4. Okay, so the derivative is ln of 10. Saan nanggaling yun, sir? ln of 10. So based sa formula or rule, meron siyang ln of a. E 10 yung base natin, kaya ln of 10. Times, copy yung buong function, which is 10 raised to 5x minus 4. Oops, meron pang derivative yung exponent. So we get, or we have to multiply it to 5. Simplify, 5 ln of 10 is equal times 10 raised to 5x minus 4. That is already a final answer. As observed, this is like the derivative of exponential function with base e but multiplied to ln of a. Kasi nga, again, hindi na e yung ating base. Okay, so wag malilito. Para sa logarithm, okay, kapag ang base natin ay e, pag natural logarithm, okay, so bumababa lang yung ating derivative. So y prime is 1 over, okay, kung ano man yung function, okay, u of x multiply to the derivative nung ating given na function or yung kasama ni ln. Kapag naman may base na hindi e, okay, mamumultiply lang sa, okay, parang ganito lang din, pero mamumultiply sa 1 all over logarithm of, or 1 over ln of a. Okay, tapos copy na yung parang nagde-derivative tayo ng natural logarithm function. So, multiply to the derivative of, okay, yung kasama ng ating logarithm. For exponent, okay, dalawa rin yan. With exponent or with base e, tapos meron siyang u of x or any function. Tapos ito naman, a yung ating base, tapos naka-raise din sa function. Pag may base e, simply copy u of x and then the derivative of the denominator. Derivative of exponent rather. Kapag naman hindi yung base natin, parang ganito lang din, copy, tas derivative na exponent, pero madadagdagan ng natural logarithm of a. Tapos, copy na. E raised to u of x or a raised to u of x multiplied to the derivative of the exponents. Okay, so that is the summarized for the derivative of the logarithm and exponent. All right, so now we have finished our lesson, part 1 and part 2. So you can go now to your Google Classroom for week 5 activities. So only written works. With that, thank you very much for listening in our lesson. I hope you learned a lot for this week.